All right, so topic 3 is on control flows, functions, and statistics. But before we start, quick question on what Git Stash is. So Git Stash is kind of a way to deal with conflicts. And so I actually ran into a thing that I needed to do Git Stash with, I think yesterday when I was demonstrating. Basically what I did was I made a change to the study group repo. So let me bring that up. Let's see, study groups. So what I'd done yesterday that needed me to do Git Stash was I made a change on the remote version remotely. So there are certain files that GitHub just lets you change on their platform, makes it very user-friendly, and READMEs are one of those things. And so what I did was, I think it was it Austin that had pointed out that like I had this as the old cohort. And so what I did was I just edited this on the remote, but at the same time, on my local machine, I added the new topic 3 file. So I added this topic 3 file on my local machine and made this change on the remote. And basically when I tried to git push, it saw that there was a conflict. It like had changes on the remote and changes on the local, and it didn't know which one to prioritize. Therefore I ran into a little error and it didn't let me do a git push. And so in cases like that, what a Git Stash would do, Git Stash would take your local changes, stash them aside for a while, allow you to take your remote changes, pull them down, and then after that, after you've like merged those changes from your remote to your local, now you only have new stuff in one place. You can then do, I believe it's Git Stash Pop, which unstashes your changes. And so Git Stash, you can sort of be like, all right, I'm working in the middle of something. Someone wants to do a change. All right, bring that change down. Stash my stuff aside first. Stash my stuff aside first. Bring those changes down. And all right, let's continue working on what I was working on. Does that conceptually help understand like what Git Stash is? Yeah, basically, if I'm ever like trying to push something and I forget, which I often do, I forget that I made a change remotely. I usually always just do a Git Stash, and then it just doesn't. It basically prioritizes the remote changes, and then you can like it will like get rid of your local changes first, get those remote changes, and then you can like patch your your local changes back on.
Do you have to use git clone to then pull the repo from the remote?
Oh, so pulling, you mean pulling changes from the remote?
Yeah, so like when you use git stash, will that do it all just with the git stash command, or do you then have to like clone the remote version to bring the changes down?
Gotcha, understood. So Git Stash is literally just the taking remote changes and like literally saving them somewhere else.
Okay.
The command to get new changes or get whatever remote changes is actually git pull. Either git pull or git fetch also works. But yeah, that's a good clarifying question. I guess we didn't really talk about git pull yesterday. But yeah, I guess we'll get more into this when we talk about our paired projects.
Yeah. When you take the stash and you move it back in, does it just like add it on top of what's existing? It doesn't replace anything. It just is like you'll have duplicates of the old changes and then the new changes as well, right?
So it kind of depends. So Git is actually really good at recognizing like the priority of things that you've changed. And so because of like, you've done that git pull and then you unstash whatever it is that your local changes were, most cases you shouldn't run into an issue. And sometimes you might get prompted that there's a conflict. But for those conflicts, and there will be, let's see, we'll probably get to that probably when we talk about the project, but you can actually open up your text editor and it'll show you what differences there are, and you can just manually go in and like pick and choose what to keep, what not to keep. Yeah, it's actually pretty user-friendly, depending on your text editor, and we'll get into text editors. I guess also when we talk about the projects, but different text editors have like different colors that show up like what changes where the remote changes, what are like the stash changes, and it's just really easy to see like what to delete. So you can basically go in and like manually like highlight whatever lines you want to keep. But yeah.
Even when they are in two different files, we get the conflicts.
If they're two different files, let's see. So if they're in two different files, yeah.
For example, in this example, you change the readme.md and you add the phase1 file. So these are two different files and we get the conflict, right?
Yeah, yeah, it does depend. The thing is, I think that because I was making like a direct edit, it wasn't sure whether, Git wasn't too sure whether like which one to prioritize. Sometimes if I were to add like new lines to a README or add in new files, so purely an additive change, it more likely will be able to detect that, all right, this is definitely like an update, if that makes sense. There's like a bunch of rules in like how Git recognizes what changes to prioritize and which ones they know are definitely like update changes. Because I literally went in and only updated like a chunk of text, I think that it wasn't too sure like which version to keep. So yeah, usually it's more intuitive, but yeah, sometimes you will run into these like conflicts, and it just wasn't sure.
So it's more likely to happen in the same branch. So we are in separate branches, it doesn't happen, right?
Yeah, so if you're in a separate branch, and we will talk about branches way more in depthly in a few weeks, but you can do your git push and everything to a branch, and it will have nothing to do with any other branches actually. If that, I don't know if that it makes things a little more confusing, but if you're working off a single branch, it basically won't affect any of your other branches until you want to merge your branches together.
Okay, thank you.
Yeah, I think a lot of this will make more concrete sense when we have like the context of our project to work on. But cool. So any questions before we get into topic 3?
No, please.
Sorry, I need to go grab some water really quick. Sorry guys, a lot of like one-on-ones in a row, a lot of talking. All right, so for topic 3, what we're gonna go through mainly are, let's see, we're gonna talk about Lambda functions. And for our entire course, there's actually a specific lesson on Lambdas, but that only comes in, I think, topic 5. But I'm gonna talk about the 2 out of 3 ways we'll be using Lambdas for our purposes. I'm also going to be talking about different ways to do for loops, making lists from lists. And I don't know if anyone has gotten to this soccer dictionary yet, but I'm going to talk about this data structure a little bit more and why it's important to like get to know this data structure very well. And then quick, just conceptual stuff on like these summary statistics that they talk about at the end of topic 3. Questions before we begin? All right, so Lambdas. Lambdas are a little bit confusing. I don't actually know if Lambdas are still in the bootcamp prep. Does anyone remember seeing Lambdas? All right, I know there's actually a couple different versions. There's like 2 versions of bootcamp prep. So yeah, I'm not sure if all of them still have Lambdas, but Lambdas are actually something that are more used in a different realm of programming known as dynamic programming, which is very different from what we do in Python. So in Python, the realm of programming that Python belongs to is functional programming. Just because in Python, we define a lot of functions to do what we need to do. There are many different kinds of programming. I am honestly not familiar with the other kinds either. But just know that Lambdas is more of a functional programming element. but useful for us in certain contexts. And I will go through, there are 3 main ways we use lambdas in this course. One of them is sorting, which actually some of you saw in this Macbeth lab, and I'm going to talk more intricately about how that works. We also use lambdas in maps and filters, which I'll go through as well. And finally, in pandas. And pandas is where that lambda section actually first comes up. So we'll talk about the pandas part when we get there, but first I'm going to talk about sorting and also maps and filters. So just to start, I think a bunch of you gave me questions about this Macbeth lab this week. So let's go through how that lambda worked in that sorting function. So let's start. This was the code that was provided. You're getting, I guess, the text from Macbeth. And I think the lab wanted you to do like a really simple analysis of the text with basically doing like a word count. Like what are the most popular words that came up? So all right. This is all the code that was copied from the solutions. And let's see where we ended up right before using the lambda. We basically ended up with a list of tuples where the first element is, I guess, the word. And the second element is how many times that word showed up. Of course, there's many different ways you can clean this data. So you can see here, like this like string of like, I don't know how many asterisks there are here, apparently comes up twice. And so we'll get more into data cleaning next week. But yeah, many different ways you can clean this. I actually have seen some of your labs where you clean things differently from the way the solutions did it, and that's awesome that you did that. But cool. So this is where we ended up right before we needed to sort. So what we have is a list of tuples, and we want to see what the top 25 words are. So this list of tuples isn't sorted, and the way we want to sort it is by its second element. We want to sort it by its second element and ascending to a big number to small number, so descending. All right, so there are a couple elements to this line here. I think the easiest, let's start like breaking it down. So this index 25 basically takes the first 25 things in that list. And then there's this sorted method. So this sorted method is a built-in Python method. So let's actually do a quick Google on the documentation for sorted. Let's see, Python sorted, I like W3 schools, and let's take a look at this. So sorted is used to return a sorted list of any iterable object, and the syntax is used like this. Up to 3 arguments, the first one being the iterable object, and as you can see here, it is a required argument. It is whatever it is you're sorting. The next thing we're sorting is the key. That's where that lambda came in, and I'll explain more on that later. But the key basically tells us, tells the function how you want to sort that iterable object.
Would you mind showing like examples of it, like redo the sorted part of the, yeah.
Yeah, absolutely. I'll talk about sorting it with that lambda function, and I'll show some other examples of other keys that you can give into sorted.
Thank you.
Of course. And then finally, the third argument you have is reverse, and you can see that it's a Boolean, true or false. All right. Oh, one thing to note is that this key takes in a function to execute to decide the order. So that's one thing to note, that it takes in a function. And that's kind of why we have to use lambda. All right, so let's go back to the Macbeth example we're looking at. So you can see here, we have the 3 arguments. We have this list of tuples, the thing that we want to sort. Reverse equals true because we want it to go descending order. And now this lambda part, which is, I think, what most people were stumped on because we hadn't talked about lambdas yet. So lambdas are actually like defining mini functions without actually defining them. I know that doesn't really make sense, but a lambda is technically a function. Especially when you're using lambda on something that's iterable, it kind of has this argument x that works very similarly to the temporary variable in a for loop. So like, you know, when you have like a for I in something, this X here works in a very similar way. So lambda X, every X basically points to every element in whatever object you're iterating over. And since each X refers to a tuple, what comes after the colon is the part of X to look at as the key. So what that means is that because each X is the tuple, and we know we want to sort it by the second element of the tuple, that's why we feed it in X index 1, because we want it to look at the second element of every tuple.
Why X though?
It can be any letter. Yeah, that's a good
Yeah.
question. It can be literally, so let me run this just to see what comes up.
X takes place of the first part of each tuple. So for example, project is X in this case.
Let's see. So each X would refer to each tuple. So X as a
The whole
whole
thing.
refers to the tuple. Yeah. So
Oh.
X refers to the tuple. That's why X index 1 refers to the second element in each tuple. Does that make sense?
Yeah, thank you.
Of course. So let's see. So running this, we get this result. We get the first 25 sorted counts. And just to illustrate the point, this can be anything. It can be lambda words index 1, and it gives us the exact same result. Lambdas is something that is kind of complicated to grasp because you're kind of like defining this function without formally defining it. In these next couple examples, I think it'll make it a little bit more clear. That's how, like, it was honestly through doing maps and filters that I understood how lambdas really worked. But yeah, let me actually look up some other ways that we can sort. I guess first of all, let's turn it back to X because I don't know. I personally like X better. If we were to sort something by X0, I wonder if this will, if you can, because I think you can sort strings. Cool, yeah. If you sort by the word, it'll sort by, I guess in sorting strings, you sort by symbols last. And so that's why all the ones that start with symbols come up first. And so that's just showing, telling us which thing to look at. Now, if you remember, the key actually took in a function, right? The key took in a function. So technically, if there was something a little bit more complicated, we could sort it by something else. So let's just try this example. I've never tried this before, so let's see if this works. So let's just say I want to sort by the second letter of each word. Not sure why we want to do that, but let's just see if this will work. Let's say I want to sort by the second letter of every word. In that case, actually, I think there's a way to just do this by this. I think I might be able to do this.
Oh, we do it.
All right, never mind. I guess not this, but
yeah.
All right, let's actually go with this defining a function. Define second letter. And then what we actually will give in here is the tuple. And I'll explain how I construct this later. I should not use the word tuple because tuple is a keyword. And then what I want to do is return, let's see, tuple index 0, and then I think 1. And what that's going to do is it's going to look at, for each tuple, look at the first element, and then within the first element, look at the second element. Can anyone think of why this might not work? Of like some cases where this might not work. That I'm looking for the second letter in each word.
There's only one letter in the word.
Absolutely, there are definitely words in here. I think there's like A, there's like I. So there are going to be situations where this is not going to come up. So let's see if an if statement will work. Let's see, if length of tuple 0 is more than 1, and I am not doing this properly, we're going to return tuple 0, 1. I think this might be able to work. All right, so what I've done here is I've defined a function that's gonna run on each element of the list that we're sorting. So when we're working with lambdas, you have to remember that each of these x's refers to a single element of whatever this big list we're sorting is. So in this case, I would want my function, and in this case, the function was lambda x. I would want this function to run on each tuple, because each tuple is the element. And so that's why my input to this function is the tuple. And hopefully this works. If not, I will have to get back to you all, but fingers crossed, we should be able to do something like this, where lambda x equals the second letter x. So what this means is that with every x, the key it's gonna look up is it's gonna go through this function, look what this function returns, which hopefully is the second letter of each word, and sort it that way. It might run into an issue because I'm not sure if like what it's gonna do for the things that are one letter words. So I might have to get back to you on this, but let's fingers crossed and see. All right, that's what I thought.
Second letter isn't defined though, right?
What is that?
Second letter isn't defined though.
Yeah. Second letter is technically defined as this function. Yeah, but all good. I will get back to you all on this. I will solve this problem. But basically what I wanted to show is that you can define any function, and depending on what it is you're sorting, you should be able to sort by that if it's not something as simple as, picking a specific element of a tuple. But yeah, I'm gonna figure this out, let y'all know. All right, next thing with lambda, let's not look at that. I don't want to see my failure anymore. All right. Next thing we use lambdas for are for maps and filters. And this is actually something that I found very, very useful in like just working with Python and I guess cleaning up data. So here I'm just gonna define this list L, 1, 2, 3, 4, 5, 6. So let's sort of see what's happening here. We're gonna start with a map. And what a map function does is it maps x plus 2 to every element of the list. And let me break this down after I run this. Since L is 1, 2, 3, 4, 5, 6, I want to do x plus 2 to every element. Hopefully we end up with 3, 4, 5, 6, 7, 8. So yeah, that's what it is. Let me break this down. So here we have kind of three things going on. We have our lambda, and our lambda is x colon x plus 2. And so for each x of whatever it is, we want to do x plus 2. And that's like kind of the temporary function that we're defining. So there's lambda. The next thing we have is map. So map is another built-in function. So let's actually take a look at what map is. Map is an object that is bounded in some, I forget what the term is. It's a bounded method. So basically, stuff is happening here, it just doesn't display, but map takes in two arguments. Map takes in a function and something to map the function on. So as you can see here, it's taking in the function and L is the list that we want to do it on. Let me actually quickly look up the Python map documentation. And let's see, there we go, W3 schools. All right. So syntax of map, the map executes a specific function for each item in an iterable. And so you can see here, there's the function, there's the iterable. And you can see here, let's see. Yeah, that's, let's go back to our example after this, but two arguments, function and iterable. So same thing here, in our map, we're giving it the function of x plus 2, and we're giving it the iterable L. And just kind of annoying thing, the map is a bounded object, so it doesn't show up until you wrap it in list. So very similarly, you can actually do this without, a lambda, just to demonstrate map. Let's just do this exact same thing, but let's define a function to add 2 to things. So let's define a function called plus 2. And it'll take in, and in this case, each element of our list is an integer. So let's just use I, and we're gonna return I plus 2. So once we've defined that, this is one way to do it. this is another way. We're gonna, instead of doing lambda x plus 2, we can do plus 2. And so we just feed it in. We actually don't have to give it this first argument because it knows automatically, especially if the function just takes in that one argument, it knows to feed in each element of L. So map is something pretty useful if you know you want to perform the same operation on every element in a list. So that's a pretty helpful thing. I think map is a very Pythonic, also a very JavaScript thing, if I'm not wrong. But yeah, map is pretty useful. But I'll actually show an even better way to do maps right after this. Any questions on this map function? Awesome. Because another thing I wanted to talk about was filtering. Filtering, I actually end up using more just because, you want to filter out stuff that, you don't want in your data. So here has a very, very similar syntax to map. So let's like make things a little clearer by splitting them up. Here you can see I am filtering to only keep elements that satisfy a condition. And my condition here, I define as x modulo 2 equals to 0 and double equal sign because we're looking for an equivalence, not assignment. And so kind of similar to that, we feed into lambda, or in this case, the condition that is built into the lambda. And filter, very similar to map, takes in 2 arguments. I think I'll be able to look this up. Let me see. Let's do Python filter. And with Python filter, exactly the same inputs, function, iterable. So if we go back here, this is the function that we're looking for to check that x modulo 2 is equal to 0 and iterating over L. Same format because filter is similar to lambda, similar to map in the sense that it's actually going to show you a filter object. We just need to coerce it into a list to have it output 2, 4, 6 from 1, 2, 3, 4, 5, 6. Questions on that?
I just had a question kind of in general with filter and map that they seem kind of like similar to doing loops.
Yeah.
And like one would be, I guess, I don't know if there's like a difference between using a for loop and using like a map lambda function, for example, like when we would need to use one versus the other, or if they're kind of interchangeable depending on what you want to do.
Yeah, they're actually interchangeable. This is something that I've actually brought up to some of you during one-on-ones, but as you get used to coding in Python, everyone sort of develops their own style of coding. And that's known as syntactic sugar. So you develop your own style of coding. I personally like doing, I prefer doing filter lambdas, but there's also the style of, creating a new list, iterating through that list and if statements, and then just like appending to that list. I think through some of these labs, y'all might have done that already. So yeah, different ways to do the exact same thing. They are actually, I believe, by memory and also speed, just as efficient. So yeah.
Okay.
I'm actually going to outline that difference in this very next section. But before we get there, the 2 out of 3 ways that I use lambdas in Python are in sorting, in doing maps and filters, and also in pandas. And we'll get to that pandas when we get there. All right, so making lists for lists. This is exactly what Sarah was getting to, where there are a bunch of ways to do the same thing. Making lists for lists. This is something I wanted to bring up because there's this idea of list comprehension. List comprehension is a very Pythonic thing. It is something that's like a very Python specific capability. And it's my preferred way to construct lists from other lists. Just because I just like the way it looks. To me, that's the clearest way to construct a list. It's really up to you whether you like it or not, but I think it's a good idea for everyone to be aware of what this is, just in case you come across some of this syntax. So all right, we have our list L, and let's just bring that back here of 1, 2, 3, 4, 5, 6. Let's just say we want to do the same thing. We wanted to go from 1, 2, 3, 4, 5, 6 to 3, 4, 5, 6, 7, 8. We just want to add 2 to every element. There are actually 3 different ways that we can do this that I'm aware of, at least. First, I think the most obvious way to do it is you construct a new list and then loop through the list and append the new values to that new list. So that's what I'm doing in this first example here, creating this new empty list for X in L. For every element in L, we're gonna append to new the element plus 2. And so that will bring us to 3, 4, 5, 6, 7, 8. And so that's one way that we can do this. The second way to do this is, as I just showed up here, list map lambda. List map lambda brings you from, what's this, 4 lines, or technically 3 lines, to a single line. So a little bit more compact. Might be a little less clear what's happening. If someone who's not familiar with, the syntax of map, something that we want to also make sure that we have in our code is that it's easily read. And so you can either put a bunch of comments saying like, all right, this is how map works and this is what I'm doing here. Or you can do something like this, which like someone very new to code would also understand. The other way I wanted to talk about is list comprehension. I think that this method is just, I don't know, to me at least, very short and sweet, very elegant, and very clear what's going on. And if I run this one line, it brings us the same result. Now, what are the elements here? There's a for loop going on, and there is that x plus 2. And so how do we construct something like this? I know this is a very simple example, but I do use this a lot. And so the way of constructing this is pretty much the same. I always start with an empty list. And I think about, all right, first, what am I iterating over? I'm iterating over L. So I'll just do like my for X in L. After that, what am I doing to each element in L? I'm doing X plus 2 and just put that at the start of that list. And Python just knows to read this as whatever the function is that you're applying to every element of that list. It just knows that for some reason.
Why are you putting the for loop in a list?
Yeah, so this is actually the method of list comprehension. The method of list comprehension is having a for loop in a list. Yeah. And it's just, to me, at least it's like a balance between clarity and also simple way to do the same thing that we're doing with these 4 lines. We're doing in one line here.
Question, how would you create a new list with that though?
Oh yeah, you could literally just like assign this to a variable. It knows to do, let's see, new list equals to x plus 2 for x and L, and let's just output new list.
Got
There
you.
we go. Yeah, I know, it's great. When I found out about this, my life was changed. But yeah, any other questions about this? Yeah, I personally like list comprehensions. I think it's a good thing to at least try and practice doing once in a while. And when you can use a list comprehension is if you find yourself thinking, all right, this is how I'm going to do it. I'm going to do the same thing to every element in a list, but I'm appending it to a new list. This is technically doing the same thing, but just in one line. And I feel like it's kind of clear what's going on, that you're doing x plus 2 for every x in L. But I mean, if you try this and it's still confusing and you don't like it, by all means, do whatever method you like the best.
Could
This
you
only
use this?
works,
Sorry, go ahead.
this only works for this?
Great question. The next line here, I'm actually going to show you how you can do it in dictionaries as well. But
Okay.
yeah, you can do it in, you can do it in the list and you can do it in a dictionary. Asher, you were about to ask something?
Yeah, could you use this method to sort?
Could you use this method to sort? I have never tried to sort it. I don't think so. But you can also add in filters. You can definitely use this method to filter as well. And I'll also show that in like 2 cells.
Instead of x plus 2, could you like convert everything to a string or convert everything to an integer or something like that?
Absolutely. So we can actually do string of x for x and L, and you'll see that everything becomes a string. So pretty much
Awesome.
anything that you find yourself being able to do here, Or if you like want to do something more complicated, maybe string of like x plus 6. Yeah, you can also define a function and have it apply that function in this for loop. So I think I had the function that I had up here +2. Here I would do +2, and here you do have to feed it in x, and it'll do that as well. Yeah. I'm a big fan of list comprehensions.
Yay.
Yeah, it's a good
Can you
one.
also use this if you have multiple lines of commands that you want to do in that loop?
Multiple lines of commands that you want to do in the loop. Let's see. If you have multiple lines of commands, I would do it I would first define it in a function, and then you could use it in that loop. So like how I did that +2 function, if like in that function you define it and have it do like a bunch of other things, you can do that as well. So actually let me like try something. Let me try
That's
something there.
complicated.
So let's say like, all right, we have our I, which is an integer. And let's say we want to take, I don't know, let's do a equals to I plus 7. And then we want to return new number is, actually let me do, is string of A. So let's see that. So this is just an example of like, I don't know, this doesn't make any sense right now, but it's going to show that we can define any function we want and use it in a list comprehension. There we go. So I did that, and depending on what your function is, you can do whatever you want in that function really, as long as you make sure that that function will work on each element in the list.
Okay.
So it'd be really good for data cleaning for like stripping, you know,
Yeah.
bases.
Yeah, absolutely. Yeah, like in that example, I'm not sure if they do it here. Yeah, I guess not for this example, but let's say you wanted to do, yeah, actually let's do this. In counts, let's say we want to turn every string in count to lowercase. So what we would do here, the thing we're iterating through is the list counts, and each element is a tuple. And so let's do for t in counts, t for tuple. And then let's just return the lowercase of the word. And so we're just going to take t0 dot lower. Dot lower. And of course, you can assign that to a variable if needed. And that just did everything and lowercase all of these words. Yeah, so it's a really neat way to do data cleaning. I'm a big fan. So that's list comprehension. I also want to show you guys dictionary comprehension because I had known about list comprehension for like months. And then someone told me that that dictionary comprehension was a thing, and like that blew my mind. So with dictionary comprehension, syntactically, it's the same. You have the for loop, but instead of just having like a single function, you actually can define both a key and a value. Actually, yeah, let's try this first. For x and L, I, for some reason, want the key to be x and the value to be x plus 1. And so same structure, for loop first, a for loop at the end, and then what you want to appear in that new dictionary at the start. And so when this comes up, you can see here, not the best example, but I just thought of a better one. 1 is 2, 2 is 3, 3 is 4, 4 is 5, blah, blah, blah. So simple example of a dictionary comprehension. So example that I just thought of is we have these, like this list of tuples over here, right? Let's turn this list of tuples into a dictionary. So what we have here is we have counts, right? Which is the thing that we're gonna loop through. So again, for t in counts, what do I want? Let's say I want to have the word to be the key and the number, the count to be the value. So I can just do t index 0 because the first thing of the tuple is the word, and colon, T index 1 for T in counts. And that, hopefully, yeah, will bring us to a dictionary where each word and count is an element in this dictionary. Cool. This is actually pretty helpful, especially when you want to like, another really helpful thing is like sometimes you have dictionaries that are like flipped around that have like your key where the value should be and the value where the key should be. Very easy way to fix that is to just do like T1, T0. And I mean, for this example, we don't need that, but this is what it is. And the reason why this dictionary is so, oh, yeah?
Sorry, you do this over a list then, right? Like everything that you're iterating over is a list. You wouldn't like iterate through a dictionary.
Great question. We can also do this. We can do dictionary comprehension over a dictionary. And I will demonstrate that right after this. I also wanted to point out that this dictionary is a lot shorter than our original dictionary. And does anyone know why?
No, ma'am. Please explain.
No guesses?
Well, you would have keys that were duplicates.
Absolutely, yeah. The one thing about dictionaries to always remember is that you don't have, your keys can't be duplicated. So basically, there are probably multiple words that only appeared once. And because of that, they all probably just like collapsed into one. I am not too sure how it decides which one to keep. I'm guessing they just keep the last one, but to be honest, I'm not too sure. But something to just keep in mind because dictionary keys are always unique. Just to quickly walk through how I can do comprehension over a dictionary. Earlier we had, let's start with this dictionary actually. So you started with this dictionary of like word colon count. And let's just call this word counts. So word counts are here. We can also do a dictionary comprehension over this dictionary. One thing to remember, dictionaries themselves are not super iterable. Does anyone remember the method that we use on a dictionary to make it iterable? We had talked about this 2 days ago. It's like a dot something that you put at the end of a dictionary.
From keys?
Dot items.
Dot keys was close. Dot keys technically would make it iterable as well, but dot items is the one that I was thinking of because dot items will let you keep both the keys and the values. Dot items literally, actually in this case, would turn this word counts back to this, just because this is iterable. But let's just say we had something more complicated and we wanted to take this dictionary and change it to a different dictionary. So dictionary comprehension, we want to do for word in word counts dot items. Always remember to do dot items. We can do that, and I'll show a slightly different way where you don't have to do the dot items. Wait, actually, yeah, no, you always have to do the dot items, but I'm going to show you 2 ways anyways. So let's say you want to like just add 1 to the word count. You would do W:0 becomes W index 1, sorry, plus 1. And that just adds 1 to every word count. And if we run this, there's so much stuff. But here you can see that this becomes from 1 to 2 because we're adding 1. And that's like dictionary comprehension. The other thing that I wanted to mention is if we remember that 2 variable for loop from before, because word counts dot items basically has like a key and a value. If anyone sort of remembers like the K and V in word counts dot items, instead of having to index 0 and 1, because Python knows automatically to unpack the 2 variables to K and V, you can, instead of doing W0, have K and then V plus 1. And that gives us the same result of like starting with 2. Yeah, it starts 1 through 23, and then this goes 2, 3, 24. All the ways to do comprehension. Comprehension is great. But yeah, I know this lab talks about functions and loops. And these are all different ways to do loops. it doesn't as explicitly have the structure of doing a for loop with like the colon and all the other things, but they're just, I think, more Pythonic ways of doing logic flows. Any questions on this?
If we want to write the exactly same command with a map function, how would it be?
So map function, let's see a map function. Oh, to map a +1 for everything. Yeah, we can, let's see, can we do that? I think we should be able to do that. We would end up doing, let me try it first before I explain. We would have to do a lambda, and then lambda k and v, and then we would do k and v +1, I think. Usually if I can do it this way, I wouldn't go back to a lambda, so that's why I'm trying to like figure it out before I explain it, but let's see if this works. It'd be something similar to this, where you can actually unpack it with k and v out of curiosity. What do I do here? K and v, k, v +1. Okay, maybe this. Let's try this. Okay. One more try, and then I will get back to you. Lambda x is x0 and x1. All right, kind of. So I think with dictionaries in map lambdas, I feel like the colon might throw it off, because in a dictionary you have to define key and value, and because lambda has that colon, or maybe I'm just not thinking of a workaround to this right now, but off the top of my head, you would have to, usually when I'm doing like lambdas, it's for lists, not so much for dictionaries. But if anyone figures it out, let me know. I will also think on this a little more.
Imagine having multiple tools in your toolbox, and you start to understand different tools and how it's used. So over time, you'll figure out your own way of coding. At least that's what I'm perceiving how this is gonna go.
Absolutely. I think like, especially starting next week, every morning I'm gonna send out a coding problem. And what I hope is that for those of you who do attempt those problems, you will like post your answers under in a thread, and you'll see the different ways that people code. And just being exposed to like, different methods of solving a problem will be just really, really beneficial.
There you go.
Would that mapping work if instead of a lambda, you had already defined a function?
Yeah, I think
that wouldn't use the colon?
Yeah, I actually think that might work. I don't want to try that right now, because I do have one more thing I want to talk about by the end of the hour, but yes, I think that would work, yes. Let's see. All right, anything else about all of these methods of doing lists and dictionaries? This part isn't covered in the curriculum at all, but I do think it is important to know or be aware of, because I do believe that some of the solutions do end up doing some sort of comprehension. So just good to know that this exists. All right, last thing I wanted to talk about, since we don't have too much time, I wanted to talk about nested dictionaries, and I'm going to allude to why they're important. A lot of data just comes in nested dictionaries. We're going to actually see in section 9, when we work with APIs and JSON files, a lot of data comes in really, really nested dictionaries, and they are a pain to figure out. In terms of like, it's just very messy. It just looks really, really messy. It's not something that you can visually pull apart. And so I just wanted to quickly talk about like what I usually do when confronted with a nested dictionary. This technically, fortunately, is not a typical nested dictionary, because if you can see, the first bracket is the square bracket. So it's technically a list of dictionaries, but nested within are dictionaries and more dictionaries.
Let me explain this to them. This is like tabbing. So,
yeah.
So once they understand the concept of tabbing, they'll start to figure out how to go through the list of dictionary.
Absolutely. Yeah. There are like different websites that you can actually copy and paste your dictionary into, and they'll show you what the structure of it. But just for the purpose of like, exploring your data, let me see if I can collapse this. Can't collapse this. But for exploring your data, these are some things that I just like to do to explore. First, let me just comment these out. By the way, the shortcut to comment things out, if we don't know yet, is Command ? Or Control ? On a Windows. It's just like really handy to have to comment out lines. But usually what I like to do is first take a look at what type of data I'm looking at. And I like print functions a lot, so let's actually take a look at all three of these. So what I have here, the type of a soccer match is a list. There are 2 elements in that list, and usually if it's a list, I like to take a look at the first element in the list just to see what I'm dealing with. And so this is something I typically do when I'm like first confronted with like a huge dictionary. Take a look at what's in there. So all right, I now know that there are 2 elements, and hopefully both elements sort of look something like this. Next, what I want to do is inspect this first element. So soccer match 0. Let's take a look at what the type of that is. So that itself is a dictionary. And when I have a dictionary, what I like to do is take a look at its keys. Because from its keys, we can sort of figure out what are the important things that we might want to keep or might want to look more into. And yeah, well, type of keys is keys, but we also just want to take a look at what the keys are. And now you can see that there's home, away, country, all of those stats. And then basically in your lab, something that's just always good to do is to look at your questions. And I have a couple of questions written down here that I was hoping to go through, but I can leave as a challenge for you all to complete. But basically, based on my questions, I will like, for example, here, they're taking a look at players. How many players have shirt numbers, have even shirt numbers? And here I'm talking about like player names and shirt numbers, and I'm gonna sum them till they reach 100. So based on that, I know that I'm gonna work with a lot of player data. And so based on that, or based on whatever analysis you're doing, you might wanna look further into that. And based on looking at the keys, I see that there's a player key. Let's take a look at what that is. So I have players, which gives us this long list of stuff. Take a look at the type of it, which, I mean, it's a list now. How long that list is, things like that. So things that you're gonna be using over and over again: type, length, keys, just a lot of things that you're gonna be using to explore the data that you're given. Let's see, we're almost at time. But yeah.
Can't keep up. I have to rewatch the video a couple times to actually understand stuff.
Yeah, I know. I talk pretty fast. I like have to try and compress like about 6-7 hours worth of stuff into 1 hour. So I really apologize. We're talking so fast. But happy to clarify anything during one-on-ones. But yeah, one quick thing that I wanted to mention is sometimes, especially if your lab is asking you questions and they aren't very specific on what they're asking, you can do a lot of things in the intermediate to make things easier for you. So based on these questions, they're looking at players, shirt numbers, and like basically stuff about players. And based on that, I can sort of like, through looking at my data, figure out that if I want to solve these problems, I'm gonna end up using players from 2 separate dixionaries. I guess I didn't have time to go through what this is as in-depth as I wanted to, but basically there are 2 separate dictionaries in soccer match, 1 home team and 1 away team. And for me to do an analysis on both of them, it requires me like iterating through each dictionary separately and then finding a way to put that information together. However, there's a way to be a little bit more efficient about this, because I know that none of these questions care about whether the players are from the home team or away team. I can actually manipulate my data and make it in a format that's a little easier for me to answer these questions later on. And this is something that definitely trains your problem solving. And so, for example, I know that all my player information is in soccer match 0 and also in soccer match 1. And they're both different lists of dictionaries of players. something I would do in the intermediate before doing these functions about players is just putting these two lists together, because we don't care about which team the players are from. We just want to look at their shirt numbers, I guess. So I would just create a new variable or store my data in a format that I don't have to loop through two separate things. So what I'm doing here is I'm creating this one list, and because you can use the plus sign with lists, I'm just making one huge list with all my players all in one. So when I have to do my loops and like solve these functions, I don't have to do it in two separate places. And this is actually something that is good to think about, especially when you have nested dictionaries, especially if you have to get down into like different layers of the dictionary to get like different pieces of information.
I find it helpful if you, the students rewrite the little codes that she's presenting. And so you start to understand the tool itself. All right.
Yeah, absolutely. I think it's really, I'm really just showing you guys these tips and tricks that have made things for me easier. And yeah, for sure. So when writing my functions, I think it's easier to run the function on this. And maybe I would call this list something like all players. And then I can write these functions on this entire list rather than writing the function on this list of two big dictionaries. And so that's just like the idea of like, it's a combination of like scoping, of like, I don't know, sort of changing your data such that it's easier to manipulate than the way it was given. But yeah, those are the main things that I wanted to highlight. If you'd like, you have a lot of questions on this data already. These are a little bit more challenging. I think this one's a little bit more challenging if you want to like practice more with a while loop. Pretty much anything you do with a while loop, I believe you can do with a for loop and a break. So if you'd like, feel free to try these out. I guess really quickly for the last couple of minutes, a super summary of the second half of topic 3 is like an intro to stats. If you've never seen stats or math before, highly recommend to just go through this to just get an idea. If you don't know what the difference if you've never heard the terms mean, median, and mode, good idea to go through those sections. But for those of you who have, it's going to be a lot of that. Measures of central tendency, mean, median, and mode, and when you will want to use each, and measures of dispersion. They talk about variance and standard deviation, basically how spread out your data is. Quartiles, percentiles, basically like similar to median, but different numbers. We will come back to stats very, very in-depth in phase 2. So if you just want to give this second half of topic 3 a quick read through, will be a good primer for that. But we won't be using too much statistics in this first phase. I know there's a lot of stuff today, but any questions? Awesome. As usual, if anything comes up, feel free to send a Slack. If not, I will see you all tomorrow. Tomorrow's session is just going to be like an overview of everything that we've come across. I don't really have any specific material to talk about, so if there's anything that you would like me to clarify, it's kind of like your time to just like let me know, and I will make a list of things to talk about. But I just wanted tomorrow to be like me taking a pulse on what how the class is feeling about this first week of material. And yeah. Cool.
Are we supposed to be through topic 3 or through topic 4 by tomorrow then?
Topic 3. Topic 4 will be next Tuesday's study group.
Great.
Thank God.
Yeah, I know it's pretty intense, especially this first week. Especially topic 3 is really long. So yeah. As usual, let me know if there's anything specific you'd like me to talk about on tomorrow. If not, we can just chat and chill. And yeah, I will see you guys at your one-on-ones, and if not, tomorrow.
Thank you.
Bye, everybody.
Thank you.
Bye.
Thanks.